Hi, in this class, we will learn about the set data type of Python programming language. A set is an unordered collection of distinct items. Before we delve deeper into understanding sets, let's do a quick recap on the other collection data types we have studied so far in order to help us relate set to other collections and to understand when to use sets. We've learned about strings, lists, and tuples. Remember when we learned about the simple data types like numbers, strings, we discussed the concept of immutable and mutable. Let's look at it through a simple diagram. When you declare a variable in Python, this variable name this variable is assigned a memory address and it holds the address of the data, everything is stored in some memory location, right? So this value is at some memory location and the address of that memory location is what this variable holds on to. So we just say that this variable called name refers to the memory location which stores this value. And if you do any, since strings are immutable, meaning you can't change the values in place here, like if this holds the value XYZ, you can't do modifications here. If you do any modifications, the modified string is stored in a new memory location. And let's say we changed it to XYV. So now your variable would refer to this new memory location. That is what is going to happen. And in strings again are a collection data type. They are a sequence of characters which are stored in an ordered fashion, meaning you can read it in an index manner, you can slice it and store it as new strings. Similarly, we have lists as an ordered collection of data. Each item in a list can again be a number or string or any data type. And within a list, if an object is of the immutable type, okay, so this is important. The lists are mutable, meaning we are allowing the data within the list to be updated in place. So let's say if this list had 5 elements, so we have 5 indexes starting from, this is index 0, 1, 2, 3, 4. These are 5. So each of these elements holds on to some memory location, the memory location where the data is actually stored. So now if this points to, let's say, a string value. Now since strings itself are immutable, but lists are mutable. So if you do any modification to this list, let's call it list A. So if I just change this value to something else, so initially it was value 1. If I change it to value 2, now since the list, the string here is an immutable data type, this value 2 would be stored in a new memory location, and this element here would now refer to this memory location value 2, and it'll have some updated value. So we are able to modify this particular element here since lists are mutable. But if the object held by the list are immutable, that stays that way. It's just the reference that is being updated here. This is how the memory model will look like. So we have a variable called noble elements, which is a list. How do we know it's a list? Because we have used these square brackets. And it has 3 elements, which are strings each. So as soon as you declare the variable, you have assigned this value to the variable. So what happens is the variable is assigned a memory location. What does it hold? It holds the address to this. This is what, so it holds the address ID 7. This is the content of ID 7. The ID 7 itself contains the address of 3 elements. And what is there at those 3 addresses? At those 3 addresses, we have these values: helium, neo, argon. Okay. Now, since these strings are immutable, so now let's say, so this was supposed to be neon. There's a spelling mistake here. So we decided to fix it. We wrote this additional line of code, noble elements index 1, to change it to neon. So now what happens is, because this string is also immutable, so there is no in place edit. It's not, we are not changing the contents of this memory location ID2, but the modified value is now stored in a new memory location. Let's call it ID5, ID4. Okay, let's call it ID4. So now this value is stored in memory location ID4, and because lists are mutable, so this reference gets updated. Earlier it was pointing to ID2, now this is updated to ID4, and this is what it references to. So that's how the memory model works. And let's now understand how it works for tuples. The idea behind understanding this is, why this is important to understand is, you would exactly know how you would nest the collection data types. While using numbers and strings, fine, it's simple enough. All you have to remember is that if you do any modifications to strings, it is stored in a new memory location. So like if you have a variable called name, if you invoke this method new dot upper, or if you invoke the function new, sorry, not new, name dot replace or name dot upper or name dot lower, any modifications. So let's say initially the name contained some value and you invoke this. Now if you print name, it will still print this value because it's still referencing to the memory location of this value. When you invoke this method, the change happened, but that change was stored in a separate memory location which your variable is not pointing to. So when you print name, it still prints this. If you wanted to print this value after the uppercase, you will have to change the referencing, and this is how you do it. So that's all you need to understand while using the simple data types. But when you're using lists, tuples, or sets, it's important to understand as to what kind of data you would store in it and what happens if you make modifications to the data that you had stored within this list, tuple, or set, because that might have a huge impact depending on what your program was meant to do. So let's move ahead with seeing an example for tuple, and let's declare a tuple. Let's assign, instead of simple data types, let's assign collection data types to the tuple. Let's define a tuple with 3 lists in it. And let's see what happens if we do modifications to the list then. As we understand, tuples are immutable. So this is how lists work. Lists can also be nested. You can have list of lists. Each of these elements could be any data type. And tuples are immutable, but what happens if you store mutable data types within the immutable tuple? Let's look at it using Python notebook. Okay, so in here I have declared three lists, and how do we know it's a list? Because we have used these square brackets. So this list one has two elements, two strings, A1, A2. List B again has two elements. Then class C is the third list, which has again two elements. And then we have declared a tuple which contains these three lists. So it's a tuple of lists. And tuples are immutable, meaning, so the moment you declare the tuple itself, this variable is given, basically this value is stored in a memory location, and tu the tuple variable holds the memory address or reference to this. And what will this contain? This itself, because it's a collection data type, it will hold three memory references, and each of those memory references which will be holding the value of element 0, element 1, and element 2 respectively. Okay, so let's see what happens. So this first cell, we've just declared it. Let's print the data type. Let me just restart the kernel. So let's just print the data type of this variable, and let's see the contents. So clearly this is a class tuple, and this is what it contains. So these parentheses tell you that these are tuple. This is a tuple, and it contains these three lists: list 1, list 2, list 3. Now let's do a modification to one of these lists, because lists are mutable. So you can do modifications here. Let's, you know what, let's do a different type of modification. Let's say I append a variable to, I append an element to the first list, class A. Let's add another element A3 to it. Okay, and I run this. So now if I print class A, the list class A, what should it print? It should print three elements now, right? Okay. Oops, okay, I ran this twice. So this is being added twice. Okay, fine. When we learn sets, we'll see how we can get, how we can eliminate the duplicates using set. Okay, I am going to just restart the kernel. So we run this, and when we run this, an element A3 will be added. Now, what would happen to our tuple? So our tuple, when we had declared this tuple, this classes holds a reference to this. This again holds a reference to these three lists. But since lists are mutable and we have not changed the memory location, these three lists, okay, This is pointing to some memory location. This is pointing to some memory location. This is pointing to another memory location. Okay. And since lists are mutable, you can make in place changes here, right? So as long as, and your tuple is pointing to these memory locations. So ideally, when we did this change append, our tuple has also been updated. Let's look at it. So let's just print the value of the tuple. And yes, as we expected, because class A is still pointing to the same memory location, you updated class A, we just added a new element. So our tuple is also updated. But now if we do a slightly different modification where, this, so initially class C was C1 and C2. Now instead of making modifications to this list, we created a statement something like this. So what this statement does is, now class C would be referring to a new memory location which holds this value. So we have changed that reference. Earlier class C was pointing to a memory location which was holding on to this value. If we had made a modification with class C square brackets index number equal to, class C square brackets 1 equal to C3, our tuple would have carried the new value. But now when we do this, because class C now points to a new memory location, but our tuple still refers to the old memory location, we'll notice that the tuple hasn't been updated. The tuple will still point to the old value. Let's see. See here. So class C is updated. Earlier it was pointing to C1, C2. Now it's pointing to C1, C3. And if you look at the tuple, it still carries the value C1, C2 because our tuple is still pointing to the earlier reference of the list. So each time, so whenever you make an assignment operation, you're basically changing the memory reference. So, you can use this method ID to print the memory reference of the variable. And each time you run the program, the ID reference would change except for few numbers and few types of data which have a constant memory location. If you're new to programming, this can be a little confusing. So just remember the summary point. Okay, I'll just summarize this. So since tuple are immutable, but if you have stored objects within it which are mutable, so you can make changes to these objects, but just avoid changing these objects in this fashion. So when you do this, so you're doing a change something like this. So this class C earlier referred to this memory location. Now when you change it in this fashion, you have made it to refer to another memory location. And since your tuple was immutable, your tuple still holds this. It, because it was just storing the memory locations. It has these references to the memory locations where the data is, and it still holds this old reference. So your tuple will not be updated. So if you have mutable data within the tuple, just use these methods, add, append to make the modifications, but not this. Okay, now let's move on to sets. Okay. as we discussed earlier, sets are mutable, but they are unordered collection of data. And the most important part is that it's an unordered collection of distinct data. That means we can use sets to remove duplicates. So you can convert lists to sets, and you will notice that all the duplicates would be removed. The other important purpose of sets is that you can use all mathematical manipulations, all that you can do with sets in math can be done using the set data type. Like you have functions to calculate the intersection, to calculate the union, to calculate the difference, to find out if one set is a subset of another set. So all these mathematical operations, if you were to do this on a list, you will have to loop through it. It will require more processing memory, right? So it's much easier to do it using sets. You have functions right away to accomplish the job. Let's look at how we declare sets. So we just use these flower brackets. Everything else remains same. And since it's not indexed, just remember that you cannot modify, even though it's mutable, but you cannot modify a particular value by indexing like we used to do in lists. So there are functions available for modification, like you can add an element, you can remove an element. So there are functions for that, but you can't do any changes to a specific element using indexing. That's not supported. So this is how we create a set. Let's just restart the kernel and see how this code works. Okay, fine. So we are just declaring the set here, and here we are declaring a list, and using that list, we are creating a set. We're using this function called set, and we pass the collection of data here. Let's put some duplicates. Let's see what happens. Okay, so we have multiple threes here, we have few fours here, we have two ones here, we have two of these twos. Let's see what Python does. Okay, so the first part of code, we're just declaring this set, we're just printing it. Then in the second part of code, we had this list. We use the function called set to create a set out of this list, and observe that all the duplicates have been removed. Now this set which has been created contains only the distinct elements. That's an important part. And if you wanted to create a set from a list, you have to use this function, because sets are mutable, but they are meant to contain distinct data. So you cannot have mutable elements within sets. So when you add elements in the set, you can only add immutable things into sets. So you cannot have set of sets because set itself is mutable. Or you cannot add list as an element to set. You can add string, you can add tuple, okay, but you cannot add anything which is mutable into set. There is another class called frozen set, which is similar to set, just that it is immutable. So you can explore that if there is a need to have a immutable set. Okay, so let's just look at a few methods. So see, if you invoke this function like this, so this is a set. And now if we try to read an index, this is going to give us an error. And it should give us a type error, because type error is what we get from Python whenever we use an unsupported operation on an object. So yeah, that generates a type error. So these are few examples to show how we can use the set theory operations, mathematical operations on sets. We have a set here, we have another set here, and a third one here. This operator is for union and this ampersand is for intersection. So this statement should give us the union of the set 1 and set 2, which means it will give us all the elements which are contained in this or this without any repetition. It will just give us the distinct values. And this will create a set with those elements which are common to both of these, right? Let's see if, okay, I think we are good. So these are the other functions. You can explore these other functions. In the next part of this video, we will learn about dictionaries. To summarize this video, we had a recap session on all the collection data types we studied so far. Strings are ordered sequence of characters. So you can read a specific character using index. You can slice through a string to create a new string. Similar to lists, you can read or change. Strings are immutable. Lists are mutable, meaning you can not only read a particular index, but you can also modify it, and you can slice through the contents of a string to create a new list. Tuples are immutable, and we saw how what difference would it make if we were storing mutable data types within the immutable tuple. How do we handle that? What kind of changes will be reflected in the tuple and what kind of changes will not be reflected in the tuple? Then we learned about sets, and sets are mutable, but they are unordered collection of distinct elements. See, you can't read them or modify them using indexing. You have certain functions to do that, and you can use it to create a distinct collection of elements. You can use it for all the mathematical manipulations that you have in set theory. So that's it for this video. Thank you, and I'll see you in the part 2 of this video. Okay, bye.